We do follow-up observations with NASA's Near-Earth Object Observations program. All night long, I'm running big telescopes. One's a 24-inch, a 30-inch, and a 32-inch, and then the 50-inch is my biggest telescope. Having 4 telescopes allows me really to do 4 times as much work as the typical observatory that just has 1 telescope. So it is a huge advantage. I work on a nightly basis, and I use these telescopes to look at asteroids. We do follow-up observations for the discoveries that are made by the large sky surveys. By looking at these asteroids and measuring these asteroids, we can determine what their possibilities of actually hitting the Earth in the future are going to be. NASA provides coordinates of specific objects that they need observations on. I'm going to punch in the coordinates here. And I'm doing this remotely from inside a control room, not at the telescope. And so we look these objects up and then use those coordinates to look at a tiny piece of the sky that this object happens to be in. And then we follow those objects and define and refine orbits for those objects and reduce the uncertainty of where it's going to go in the near future. I started off as a volunteer in 2006. It's just blossomed into a full-time opportunity to work for NASA under their grant program, where I'm now doing this every single clear night. Now we're starting the observing run for 2017 KK3. You don't build a telescope that's this big without being passionate about what you do. I'm really driven to be a part of a program that's important and has importance to the future. And we're not talking about next year or the year after. We're talking about asteroids that could potentially hit the Earth 100 years from now. And the work we do today may make a difference 100 years from now.